Assalamu alaikum everyone. So today I would like to take this session to clarify the doubts that was asked by several students, right? So we will move on to the problems. So the first problem is 9x squared minus 4. Alright, how are we going to solve this 9x squared minus 4? So that is what we are going to look now. So it's going to be 3 into 3 is 9 into x squared. So this is very simple. 9 can be written as 3 into 3. X squared can be written as x squared itself. So minus 4 is there. Now 3 into 3 is going to be 3 squared into x squared. Into mark is not necessary, so you can put as x squared itself. Minus 4 should be written as, 4 can be written as 2 into 2, so it's simply 2 squared. Now if you consider this 3 squared x squared, 3 squared x squared can be written inside the bracket as 3x whole thing squared minus 2 squared. This is very simple algebra. Now 3x whole thing squared minus 2 squared is difference of 2 squares, and this can be written as 3x minus 2 into 3x plus 2, and this is the complete factorization of 9x squared minus 2. Now let us factorize x squared plus 2x. X squared plus 2x. So how are you going to factorize this now? X squared plus 2x. What is common to both of them? Simply x is common for both of them. So just take one of the x, right, from take the x out of the bracket here and take one of the x out of the bracket here. So you have taken it outside, so the remaining terms are going to go inside. So taking x out of the bracket makes this x to come here because it's x squared, meaning x into x, and you have taken x out of the bracket, so remaining term is 2, and in between you have plus, so the complete factorization is this. And even though this was a very simple problem, many of you guys have got it wrong. Let us try and solve this equation. So we have to find x. Alright, to solve this, first of all we have to think that we have x over 5, right? Can we deal with this x over 5 initially, right? So first of all, the very first thing we can do is to take this 2 to that side. When we take 2 to that side, it will be very easy for us to move on with the sum, right? Or else if we try to think that 2 plus x over 5 is equal to 3, it's going to make a big mess, right? Now I want you all to think about this. Now there's a number here, and when you divide that number by 5, it gives another number, and that number, if you add by 2, is going to make 3. So what's the number? What's this entire number? It should be simply 1. If this was 1, if this entire number was 1, how much should this x be? X should be 5, because 5 divided by 5 is 1, right? So that is what we are going to find. We are going to find what this x actually is, but we can't guess it. We can't guess it. In mathematics, we rarely guess it, right? So we should have some kind of an arithmetic way of doing this. So take this 2 to the other side. So what we are going to get is x over 5 is equal to 3. When you take this 2 to that side, plus 2 becomes minus 2. So you are going to get minus 2 here. So x over 5 is equal to 3 minus 2 is going to be 1. So in order to find how much is x, we have to multiply this side by 5. If I multiply this side by 5, I will have to multiply the other side also by 5. Now what can I do is 5 to 5 is chopped each other off. So 5 to 5 is gone. So x is going to be 1 into 5. So x is going to be 1 into 5. 1 into 5 is going to be 5. That's it. Let us try to factorize 8x squared minus 50y squared. Initially we have to make the basement properly to do this problem. You see that 8x squared minus 50y squared, majority of us think, how are we going to factorize? What is there to factorize? That is what we think. It's not difference of squares. Why it is not difference of squares? Because it is 8 and 50. 8 is not a square number. 50 is also not a square number. But we have to, if we design it properly, we can somehow do it very easily, right? So let me give you the way to do this. 8 and 50. What is common for both of them? Simply 2 is common, because 2 into 4 is 8 and 2 into 50 is 2 into 25 is 50, right? So you can take 2 out of the bracket. When you take 2 out of the bracket, you get 2, and inside the bracket is going to be 4x squared minus 25y squared. The beauty of this problem is 4 is a square number, x squared is a square number, 25 is a square number, y squared is also a square number. Now what? Now it's difference of 2 squares, right? So 2 into 4 can be written as 2 squared and x squared. So inside a common bracket you can write this as 2x squared minus 5y whole thing squared, because you know that 5 squared is 25, 5 is 25, right? So cool. Now what you can do is 2 into this 5y should be subtracted from 2x, so 2x minus 5y and you have to add 2x with 5y, so 2x plus 5y should be written here. Now altogether what we have is 2 into 2x minus 5y into 2x plus 5y. Cool. Let us step on to LCM now. We will work on this. So last time we have discussed that whenever we want to find the LCM of certain stuff, right? You might see the algebraic fractions video, so that from that you can understand that. So whenever we are having some kind of algebraic terms, first of all we have to factorize it as much as possible. Now if you consider this, it's already been factorized. Now if you consider x squared minus 22, remember this 22 is not a square number, so you can't apply difference of two squares here. So these are two terms, that's it, halas, done. So you can't do anything further, you just have to find the LCM of these two terms, right? So you can apply any method you like to find the LCM. So let me do the division method. So we have x minus 1 into x plus 2, right, comma x squared minus 22 to be our terms, x squared minus 22 to be our terms, right? So in order to find the LCM, what we are going to do is we just draw this line that we usually draw, and now we see whether there is any common terms for both of these two terms, right? So obviously there is no any common term, so we can select any one of them to continue the problem. So x minus 1, let me select x minus 1, whatever the number, whatever the algebraic term you like, you wish, you can select x minus 1, x plus 2, x squared minus 22, whatever it is, doesn't really matter. So you can use anything that you like. So first of all we will divide this by x minus 1. So divide this by x minus 1, right? So x minus 1 and x minus 1 you can divide each other, so you are going to get 1 here, the remaining stuff is going to come here, so you are going to get x plus 2 there, right? Furthermore, x squared minus 22 cannot be divided by x minus 1, x plus 2, blah blah, whatever the number you like, right? So you are going to put the same number or same algebraic expression there, so you are going to get x squared minus 22. Now you are going to select the next number, right? X minus 1 is done and dusted. Now the next number is x plus 2 or x squared minus 22, whatever the number you like, you can select. So you can select. So let me select x squared minus 22. You can select x plus 2 also, doesn't really matter, but I'll select x squared minus 22. So if I select x squared minus 22 here, x plus 2 cannot be divided by x squared minus 22, so x plus 2 should be written here, and x squared minus 22 divided by x squared minus 22, right? Same number, on top of that you have the numerator and the denominator to be the same number. 2 over 2 is 1, 5 over 5 is 1, 8 over 8 is 1. X squared minus 22 over x squared minus 20 is also 1. Now to move on with the sum, you have to, obviously, you have to select x plus 2. There's no any other option. So you are going to go with x plus 2. So you're going to get 1 here, 1 here. So up until you get 1 here, you have to continue the sum. So once you are done with it, to find the LCM, what you are going to do is you put LCM equal to, you have to multiply all these terms. So then you are done with the LCM. So you are having x minus 1 into x squared minus 22 into x plus 2, right? So this is the LCM.